Hello and welcome to this episode of Devs++. In this episode, we are going to talk about the start and termination of our C++ programs. Stay with us. So for today's discussion, we are going to have a look at the main function and see what we can learn about it. In order to do that, we are going to have a quick look at C++ standard, a pre-release version for C++ 11 that is going to do just fine for the sake of this discussion. Under section 3.6, it says that a program shall contain a global function called main, which is the designated start of the program. It is implementation defined whether a program in a freestanding environment is required to define a main function. So we are going to have a look at where this main comes from and in which environment we are running our code. In point 2, we have different overloads of the main that we are familiar with. Number 3 says that the function main shall not be used within a program. We know that. We should not call main ourselves. 4 is interesting, terminating the program without leaving the current block. For example, by calling stdexit does not destroy any object with automatic storage duration. And number 5 says a return statement in main has effect of leaving the main function, thus destroying any object with automatic storage duration and calling stdexit. And if you don't see any return statement, the effect is implicitly adding a return 0. So these are the things that we are gonna check inside our code. So this is the simplest program that we can write in C++, and I'm gonna to compile it with GCC. And the output is an elf file when we ever do that. And elf file is short for executable and linkable format, is a general file format in Linux for executables. And whenever Linux wants to run a elf file, it first looks inside it to gather some information about it. Now we can see those information for ourselves with the help of readelf command. And I'm gonna just dissect the header of the elf file, so flag-h, and I'm gonna dump it inside the file and have a look at that. And if you look at this, we see that the header is dissected for us, and entry point of our program is 1040 hex. Now the next step is we want to look at the assembly of our code and see what is this address. It is the start of our main function or not. Now I can dissect my code and disassemble my code with the help of objdump command. And flag-d does the disassembling. Now I want to intermix it with my code, so capital S, and I just dump it inside another file. And if I have a look at this and address 1040 hex, I see that it's not a start of the main, but a function named start. So what's happening here, that before the program can call our main function, there is some things need to be done. For example, to put argc and argv inside the stack frame, for example, and setting up the runtime environment and constructing object with a static storage duration, and for example, getting ready to profile and other stuff. And when our code exits from the main, also there are things to be done. For example, distracting objects, releasing memories allocated, doing, for example, any other stuff necessary that we are going to have a look at them in a minute. So basically, this function start is responsible for doing those things by, putting some things on the stack and just calling this function libc start main and passing the address of main function as a function pointer to this function. And this is where all the magic happens. Now, if you want to see what's happening really under the hood, you can look at the source code of this function, but I just mentioned a thing or two that's doing. You understand from this that the start of our program is not the main, but another function named start. Now, there's a flag inside GCC-E, that's linker flag, that says us that we can change the entry point of our program. So for example, if I want to change the name of the main to entry and change that it's also in my source code, the error that I get is that inside the object file name strt1.o and inside the function start, there is an undefined reference to main. So what's happening here is that because we are in a hosted environment that we are going to have a look in a minute, we are in a Linux. As the standard says, the starting point of program should be main, and we cannot change that. There is this file already pre-compiled with my C runtime environment that is added to my code via linker and is looking exactly and explicitly for the symbol name main. Thus, I cannot change that. However, for example, if I was in an embedded environment, a bare metal application, I could change the name of main function to whatever I desire. Okay, but how we can make sure that we are in a freestanding environment or not? If we search for a freestanding inside CPP reference, yeah, we come to this page, and this page says to us that the value of STDC hosted is defined 1 for hosted and 0 for freestanding environment. But how can we look at the value of this macro? So I'm going to show you how to do this for GCC, and for other compilers, you have to find out for yourself. So again, in GCC, we have a dash capital E flag, not to be mistaken with dash E flag for linker we introduced earlier, that says the compiler to just stop after pre-processing. So just do the pre-processing and stop. And we have dash D capital M flag that is says to preprocessor that instead of normal preprocessor output, just output the value of defines before our macros defined before running the preprocessor. So with 8 of these two flags, and if I dump it inside the file, you can see that I can get all the values defined before the preprocessor is run. And if I search for STDC as the CPU references, you can see that I'm in a hosted environment, and thus our previous conversation. But another thing that we understood was that this return 0 is not mandatory. So if I omit this and I compile my code, you can see I get no warning whatsoever. However, if I were to do this with another function and I compile it, you see that I get a warning because in the main function, the return 0 is implicitly added. However, in other function, that does not happen. So this is another difference between main function and ordinary functions. And we also understood that if we don't exit the main function, and for example, with calling stdexit, automatic storage duration objects are not cleared. Let's check that. Now, in order to test that, I introduced two new structures, foo and bar, and created one object from foo with a static storage duration and one instance of bar with automatic storage duration. Now, if I were to run this code normally, you can see that both objects are destroyed. However, if I were to add stdexit here and run it again, you can see that only foo with the static storage duration is destroyed. So that's what point number 4 in the standard was saying. There are other ways for us to exit the main function. For example, we can do std abort, and this does not do any destruction for us. You can see that nothing is destroyed. Another way that I can exit is using quick exit. And with quick exit, we also don't get destructions of the objects, so even static objects are not destroyed. And that's pretty much it. So if you remember from earlier, I said that after the main is returned, there are some codes to be run, and one of those codes is to call handlers that are registered by the user to be called after the main function has returned. So to have a look at that, we are going to have a look at the function std atexit. So this function, with 8 of this function, I can just register a function pointer to be called after the main function has exited. So to test that, I'm going to introduce a function, for example, here, and register it here. And you can see that this function is called. Now, one thing to know about atexit is that the functions are called in reverse order in which they are registered. So for example, if I introduce another function and register them this way, I should be expect that bar is run first and then foo. And if I run that, you see that bar is first called and then foo is called. Now, if I were to exit my code with quick exit, you shall be aware that atexits are not called because it's a quick exit. So in that case, you may want to use add quick exit instead of the normal atexit, so that you get a handler when you get out of the main function. So you see that foo is returned here because I registered it with add quick exit. That's pretty much it for today. I hope you all enjoyed this episode. Let me know in the comment if anything can be improved or if anything was possibly wrong, and see you next time.